Okay, so now we're going to look at converting back and forth between base 10 positional value or place value systems and place value systems with other bases. So just to recall, I know I did an example similar to this on the last video, but just to refresh your memory, this is how you convert a numeral to a numeral base 10. Convert to a numeral, in base 10. So let's take a look at a number like this one. Alright, let's take a look at a 3, 1, 2, base 4. Or let's do actually 2,312 base 4. So we're going to convert this to a base 10 numeral. So in order to convert this to a base 10 numeral, what you're going to do is you're going to take each one of these numerals and multiply it by its corresponding place value. So the place value of this one, well, let's list all the place values first. The first place value is 4 to the 0 power. The next place value is 4 to the second power. Probably need more room here. Alright. So the first place value is 4 to the 0 power, which is the ones place. The second one is 4 to the first power. 4 to the first power. The third one is 4 to the second power. And the fourth one is 4 to the third power. So we only need these 4 because we only have 4 digits in this number. Well, let's see now. So the 2 is in the ones place, plus. Then we have a 1 in the fours place, plus. Then we have a 3 in the 16s place, plus. And then we have a 2 in the 64s place. So here we have all the place values multiplied by the numeral that is in that place. So this is 2 times 64 plus 3 times 16 plus 4 times 1, or 1 times 4, plus 2 times 1. And then we're just going to do this arithmetic to convert this to a base 10 number. So this is going to be 128 plus 48 plus 4 plus 2. Let's see what this gives us. Let's see, this is 128 plus 48 plus 4 plus 2. And I get, this is the number 182, and that's base 10. You can either put a subscript of 10 on it, or you can just leave the subscript off, because anytime we write a number without a subscript, we assume that the base is 10. So that's what we did. We did something very similar to this on the last video. You look at each place value, and remember, the place values are powers of that base. So the place values are just powers of that base. And then you multiply the corresponding number in that place value by the value of the place value itself and add them all up. Alright, now I want to go back in the other direction. The other direction is a little bit trickier because we're dividing, but not too much trickier if you understand what we just did. So let's convert these numbers in base 10 already to other bases. So let's start off with let's start with this number. Example. Let's convert each of the following. Convert to the indicated base. So we're going to convert these to the indicated base. Alright, so let's start off with the number 53. And we'll convert 53 to base 4. Okay, so here's the first step, and this is probably the most important step. The first step is to find the largest power of the base, the largest power of the base, or basically find the largest place value that is less than or equal to the number you're trying to convert. So the place values are 4 to the 0, which is 1. That's smaller, but let's see. We have 4 to the 1, which is 4. That's still smaller than this number. We have 4 to the second, which is 16. That's still smaller than this number. But then 4 to the third power, 4 to the third power is actually 64, which is bigger than this number. So I said that what we're looking for is the largest place value that is less than or equal to 53. 64 is too big, so we're going to ignore 64. What we have is we have a number here that's actually going to be represented with 1, 2, 3 numerals in the base 4 system. In base 10, we can use 2 numerals, 5 and 3, 53. But in base 4, we're going to need 1, 2, 3 numerals. And we're going to need a numeral to put in each one of those place values. So here's how we start off. The first thing you want to do is find out how many groups of 16 there are in 53. How many groups of 16 there are in 53 will tell you what numeral goes in this place value. Well, let's see. In 53, let's see how many groups of 16. Well, 16 goes into 53 3 times. 3 times 16 is 48. And upon subtraction, we get that this is what? 5? So it turns out that the number that goes in this place value is a 3, because there are 3 groups of 16 in this number, 53. So the number that goes here is a 3. The next place value down is the 4's place. But now, instead of looking at the 53, we're looking at the remainder. So what we want to know is how many groups of 4, the next place value down, how many groups of 4 are there in the number 5? Well, it turns out that there's 1 group of 4 in the number 5. 1 group of 4 in the number 5. And since there's 1 group of 4 in the number 5, I just need to know what the remainder is. So I take 5, which is the remainder that I got from here, and I divide it by 4, which is the place value I just figured out that there was 1 in. The 1 is the quotient. How many times 4 goes into 5? And it leaves a remainder of 1. So now I know not only what value goes in my second place value here, but I also know what the remainder is. And all I need to do now is figure out how many times this last place value, the 1's place, goes into 1. So how many times does 1 go into 1? Well, how many groups of 1 are there in 1? There's a single group of 1 in 1. 1 times 1 is 1. And when you subtract, you get a remainder of 0. So it turns out that the number 53 base 10, if I want to write it as a base 4 number, is actually 311 base 4. So 53 base 10 is actually 311 base 4. All right, I'm going to do one last example here. So let's get rid of the 53. We won't convert it to base 4. Let's do... Let us do... Let's do 102 to base 5. Let's convert the number 102, which is in base 10. Let's convert that to a base 5 numeral. All right, so the first thing we want to do, remember, the first thing you want to do is you want to look at what place value is still less than or equal to 102. So let's start off with the place values. There's the 5 to the 0 place, the 1's place. There's the 5 to the first place, the 5's place. There's the 5 to the second place, the 25's place. And there's a 5 to the third place, which would be 125, the 125's place. This is too big. That number is bigger than that one, so we ignore that. We know that the number we're going to write, we can write using only 1, 2, 3 numerals. So the number that we're given in base 10 has 3 numerals to represent it. And now it turns out that when we convert it to base 5, we still only need 3 numerals to represent it. So that's the first step. Find the largest power of the base that is less than or equal to the given number. Then, what we're really going to do here is we're going to see how many groups of 25 there are in 102. That's a division problem. How many groups of 25 are there in 102? Well, the answer is 4, and the remainder is 2. So that's 4 with a remainder of 2. So the numeral that goes in this place value is a 4. A 4 goes in that place value. All right, so now we move on, but we're going to use the remainder this time. So we need to know how many groups of 5 there are in the remainder, which is 2. Well, how many groups of 5 are there in 2? There are 0 groups of 5 in 2. So the numeral that goes in this place value is a 0. And 0 times 5 is 0, and when you subtract, you get 2. So the remainder is still 2, and I can move on to the next place value. So now I need to know how many groups of 1 there are in 2. Well, 1 goes into 2 one time, not one time, 2 times. 2 times 1 is 2, and then when we do the subtraction, we get a remainder of 0. So it turns out that the number that goes in this last place value is a 2. And this is base 5. So I want you to notice these numerals that we're putting in each of these place values are just the quotients, 4, 0, and 2. And then we divide the next place value down by the remainder. So that is how we convert from base 10 to other bases and from other bases to base 10.